So moving on to transactions. So if you remember regarding transaction, we discussed that these are multiple queries that run with the same action. So the focus will be on how you do the current concurrent execution of the programs, what properties we might have, what's the transaction, what are the problems we have here, and how can we overcome this. So basically, concurrent execution of user programs is essential for good DBMS performance. Like you have to run multiple transactions at one time, and a user may carry all sort of operations on the data, but the DBMS is only concerned with what data is to be read from database and what data is to be written into database. So transaction meter issues are when you are doing interleaving transactions, like when multiple people are using ATMs for their cash transactions or transfer transactions. So like multiple transactions are happening at once. So how you manage those, and what happens if the server crashes? So the basic properties of transaction are asset properties, which are known as atomicity, consistency, isolation, and durability. Atomicity is basically when you are performing an action and you have, for example, 4 or 5 queries on that action. So all the actions need to be performed or no action should be performed. Consistency is if the each transaction is consistent, the database is initially consistent, then then the consistency is then it should be consistent at the end of transaction. Isolation means if you are doing two transactions or if multiple doing people are doing transactions, they are isolated. One transaction doesn't have effect on another transaction. Durability is if a transaction is complete successfully, then it affects on the database persist, or like it stays in the database forever. So atomicity means a transaction can commit after completing its actions or abort because of internal DBMS decision system crash unexpected. So if a transaction has 4 or 5 actions, either all actions are completed and it has done commit, or if some of the actions are left, then it is using abort and all the previous queries are uh, uh, rewinded. So the previous queries should be removed as well. The effect of those queries should be removed as well. A transaction interrupted in the middle could leave database inconsistent. Why? Because, for example, if you look at the example of ATM, if you have conducted a transaction of 5,000 and the amount is deducted from your account, but you haven't received the cash, so the database will be inconsistent. You don't have that amount, but it is already deducted from your account. So DBMS needs to remove the effect of partial transactions. So for example, if 2 or 3 actions have been performed, so you have to remove the actions of those transactions to ensure atomicity. So either all transaction actions are performed or none is performed. A DBMS ensures atomicity by undoing the actions of partial transactions. To enable this, the DBMS maintains a record, basically known as log, which writes everything to database. So the component of DBMS responsible for this is recovery manager. So recovery manager performs the rewinding of the aborted transaction actions. Consistency means users are responsible for ensuring transaction consistency. For example, data consistency is the property that every transaction sees a consistent database. It follows from transaction atomicity, isolation, and transaction consistency. Consistency, another example can be if you have, like you see, you have done some transaction from database and you are logging into your mobile app and still seeing that balance exists. So this is basically inconsistent. So database should be consistent. If you have performed a transaction, so the database should be consistent and it should be giving same output on all the places. Isolation means that each transaction, even though transactions may be interleaved, the net efficient is identical to execute the transaction serially. Like transaction T1 and T2 should should be separated. Like they one shouldn't affect the transaction or execution of another. So normally, what happens is T1 is followed by T2 or T2 is followed by T1. Durability means uses the log to ensure durability. It means that if you have run the commit command, then the effect of data, your transaction shouldn't be rewinded. If the system crashed before the changes made by a complete transaction are written to disk, the loss is used to remember and restore these changes. So normally a transaction basically seen by database as a series or list of actions. You write your transaction like read and write. Commonly R and W are used for read and write. And once the transaction is completed, you either write commit in front of that, or if the transaction is stopped in the middle, you write abort. So a schedule is a list of actions from a set of transactions. A well-formed schedule is the one where actions of particular transaction are in same order as they appear. Like you are reporting the actions of transactions as they are appearing. You are not reporting haphazardly. Like if the action one is performed first, then you write one, then two, then three. So you don't write, you don't take the actions from the middle and then write that in the start, or you write the initial transaction action at the end. So you write the transaction as it is happening. So if you remember, if you see here, assuming that we have an alphabetical order, so first A transaction happens, then B transaction happens, then C happens. If you see here, it is doing the reverse. So no, if A is happening first, you need to report A first, then you need to report B, and then you need to report C. So basically, a complete schedule is the one that contains, if you see at the end of this, you don't have abort or commit. So complete schedule will be one that contains an abort or commit action for every transaction that occurs, and a serial schedule is the one where actions of different transactions are not interleaved. A serializable schedule is a schedule whose effect on any consistent database instance is identical to that of some serial schedule. All different results assumes to be acceptable. It is more complicated when we have transactions that abort, and we'll assume the side effect of the transactions that are returned to the database. So two actions on same database object conflict if at least one of them is right. So what can be anomalies or what can be issues? For example, we have read write commit. So if you see here, transaction one is running. So we have read a variable A, and then we have written a variable A. Now transaction 2 is reading the same variable A. So what is happening? So transaction 2 will get the old value of A. It won't get the new value of A. Why? Because we haven't done the commit yet. So that is a write read conflict. So similarly, other conflicts can be write read and write conflict. We have write write conflicts. So if we have here transaction, we write here A, and then we are doing the abort. What is happening then? So for these issues, what we prefer is we prefer a strict two-phase locking mechanism, which is used by the transactions. So each transaction must obtain a shared lock before reading and an exclusive lock before writing. All the locks held by transaction are released when the transaction completes. So either when it is committed or it is aborted, then the locks will be released. So if a transaction holds a lock X on an object, no other transaction can get a lock S or X on that object. It is only applicable to serializable schedules. Serializable schedules are those schedules or those transactions which run simultaneously. If one transaction is being completed and then the next transaction is being run, so it won't make any sense. So they are already following. No resource will be shared between them. So the main focus or the main purpose of strict 2PL is only those transactions that run simultaneously. So aborting, if the transaction is aborted, then all actions must be undone. So most systems avoid cascading aborts by releasing locks only at a commit time. So if you are removing the locks at the commit time, this helps you avoid these issues. So normally we, if you remember in the start, we do this with the help of recovery manager and logs for which can be used for aborting purposes. So log is basically anything, any changes, any queries run on database are basically run on the log. Log records are basically kept by transaction IDs, so it is easy to